All right, so that's a so-called bareBone Arduino chip microcontroller, which means the microcontroller is not actually in the socket on the Arduino board, but that's ATmega328p microcontroller. You can see the original one has been taken out and I put it over here, and this one is the one I ordered online. I ordered probably over 50 of them, so every of you guys will get one in the class. But we still need this kind of USB cable to program our microcontroller over here. And so the USB signal, the program is being downloaded through the USB cable, and it's being converted or translated by this little chip into a UART signal to here. And then all the code are going to be transmitted through this two serial data lines to the microcontroller, right? So there's nothing running on the rest area of the Arduino board except for the USB to serial converter chip. So we are still using this board to program our microcontroller, but however, they are kind of, so the microcontroller over here is pretty independent to this original board over here, because we don't want to use this one for our car. It has a lot of redundant parts on the board. We want to make it portable. You can see I just use, after you program it, you can feel free to unplug these two data transmission lines, and you can replace the 5 volts and ground power to something else, like whatever I have over here, right? Or a battery, so whatever. So these ones this one will be portable, and the oscillator, which is a 60 megahertz oscillator, and two capacitors, and a little LED. It's a power indicator, and this is a little LED is blinking. I connect this one to this port. So on the right side, the fourth port from the bottom. So this one is actually port 12 on the Arduino board. Okay, just keep in mind. Because we are using the Arduino programmer, the Arduino IDE, so they already make a lookup table in their software to connect the pin 12 on the board to this pin. So it's actually PB4, I guess. It's port B and number 4 in the datasheet of the microcontroller. But if you're using the Arduino's IDE, you want to claim this one as pin 12. Okay, I'm going to show you how to find out all these maps in the tutorial online. Okay, and now I'm just trying to demonstrate that it's going to work independently on the breadboard instead of on the Arduino board. And I'm blinking. You can see the rate right now is actually 1 hertz. Okay, and here's the code, and I can directly make it faster. Let's change it to 100, and the same thing here to 100. And now I will program it. So be careful. There's one thing you want to configure. So go to Tools. Don't forget to change the port. And also, if you see some of the tutorials online, they will tell you want to change the board to this one. That's not true for this case. I don't know why, but just use the original option here, and it's gonna work. All right, and now directly download it. And you can see that it's blinking faster. So just trying to demonstrate you this is working perfectly. And I think there's one thing I just missed. Okay, for the reset pin here, which is this line, the green line here. If you wanna use the same reset push button on the board, I mean, you can directly just connect this one to the pin on the board here, to the reset pin from here. Okay. And if you want to just directly make a reset function on your board by yourself, which is pretty simple, I'm going to show you on the tutorial. I just add a push button and connect that pin to to the push button and a pull up resistor to the power, and then a push button to the ground. So whenever you push the push button, the voltage at this pin is being connected to the ground. You give a logic low to this pin, and the microcontroller will be reset. Okay, and that's it.